Hello, and welcome back. It has been a long day, hasn't it? You carried a lot today, more than you probably noticed at the time. You don't have to carry any of it right now. There is nothing to do here, nothing to solve, nothing to finish, nothing to remember. Tonight, we are going somewhere very far away. Not across space, but across time. 1 billion years into the future, further than any human mind was built to comfortably hold. Now, close your eyes if you'd like, let your breathing slow, and let's begin. 1 billion years is a strange kind of number. It is too large to picture, and so the mind quietly gives up trying and simply rests in the size of it. If you laid down a single grain of sand for every year that passed, you would need enough sand to bury a small house. Geologists speak of this span the way sailors speak of the ocean, respectfully and without pretending to have seen all of it. 1 billion years ago, the most complex life on Earth was a thin film of algae drifting in shallow water. 1 billion years from now, something will be drifting again, though we cannot say what. Time does not rush toward that moment. It simply continues, the way your breath continues, without needing your permission or your attention. And yet, the ground beneath you is not as still as it feels. Even now, the continents are moving at roughly the speed your fingernails grow. Over 1 billion years, that slow creep adds up to thousands of miles. The land you know will not exist in its current shape. Coastlines will vanish and reappear elsewhere, drawn by forces too patient for any camera to catch in the act. Scientists who study this call it plate tectonics, but the phrase feels too clinical for something so vast. It is closer again, perhaps more than once. Continents seem to gather and scatter in a rhythm, the way leaves settle into piles and scatter again in the wind. No one alive will see it happen. But it is happening, quietly, underfoot, in a motion too slow for any of us to feel. We still don't know exactly how many times the continents have gathered and separated since the Earth first cooled. The rock record grows fainter the further back you look, erased by the very forces that wrote it. It seems like something we should know, and perhaps one day we will know more of it. For now, it remains a soft mystery folded into stone. There is something comforting in that. Not every question needs an answer tonight. Some are allowed to simply exist, unresolved, like a held breath that never quite needs to be released. Even as you rest tonight, your body is quietly rearranging itself. Skin cells are being replaced. Old ones are flaking away, unnoticed, into the air of the room around you. In roughly 7 years, nearly every cell in your body will have been renewed in some fashion. It is a small, private echo of the continent's drift. Replacement without disappearance, the shape staying familiar even as the material beneath it changes hands. You are, quite literally, not the same collection of atoms you were a decade ago. And still, somehow, you are entirely yourself. The sun above you, the one that will rise again tomorrow, whether or not you're awake to see it, is also changing, though far too slowly for anyone to notice in a lifetime. Stars like our sun grow brighter as they age, not dimmer, as they burn through their store of hydrogen. In 1 billion years, the sun will be perhaps 10% brighter than it is tonight. That does not sound like much, but it is enough, astronomers believe, to begin nudging Earth's climate towards something warmer than anything in the planet's long history of ice ages and warm spells. The change would arrive slowly enough that 1,000 generations could live and die without noticing it had begun. Beneath that gradual brightening lies a quieter, older process. Photosynthesis depends on carbon dioxide, and as the sun brightens, weathering of rock accelerates, slowly drawing carbon dioxide out of the atmosphere. Some models suggest that within the next billion years, the concentration of carbon dioxide could fall low enough to make photosynthesis chemistry rising out of the Earth itself. If the surface someday grows inhospitable to photosynthesis, it is these quiet, sunless communities that may carry the thread of life forward the furthest. They have already been doing so for billions of years, thriving in darkness, unbothered by whatever is happening in the sky above them. There is something almost lullaby-like in that. The idea that even without light, life finds a way to keep humming along. Even now, as you breathe, you are pulling in a mixture of gases that has not always been the same. A billion years ago, Earth's atmosphere held far less oxygen than it does tonight. It took cyanobacteria, small, ancient, patient organisms, roughly 2 billion years of quiet photosynthesis to fill the sky with enough oxygen for animals like you to eventually exist. You are, in a very real sense, breathing the slow exhale of an event that began before complex life existed at all. Every breath tonight is borrowed from something extraordinarily old and extraordinarily patient. We still don't know precisely what the atmosphere will look like a billion years from now. Some models suggest a slow decline in oxygen as plant life struggles under a warming, carbon-starved world. Others suggest new forms of life may emerge to replace the old cycles, the way cyanobacteria once replaced whatever came before them. Astronomers and geologists can build careful models, layered with assumptions, but the truth is that a billion years is long enough for surprises. It seems like something we should be able to predict with certainty. And still, some soft uncertainty remains, comfortable in its not knowing. The moon, too, is drifting. Not across the sky, but away from us by about 1.5 inches each year. Over a billion years, that adds up to roughly 23,000 miles of distance gained. It will still hang there, pale and familiar, but very slightly smaller in the sky than the one you might glance up at tonight. As the moon drifts further, its gravitational grip on Earth loosens, and the length of a day slowly stretches. A billion years from now, a single day may last closer to 25 hours instead of 24. Somewhere in that extra hour, there is room for just a little more rest. Beneath that slow lunar drift lies an old story written in coral. Ancient coral fossils carry fine growth rings, not unlike a tree, and by counting them, scientists have found that days were shorter hundreds of millions of years ago, closer to 22 hours long. The coral did not know it was keeping a record. It simply grew, day by day, season by season, and in doing so it left behind a diary of time itself, etched in calcium, waiting patiently in stone to be read by someone curious enough to look. Right now, as you breathe, there are cosmic rays passing through your body. Tiny, high-energy particles born in the distant explosions of stars that died long before Earth existed. A few pass through you every second, mostly harmless, mostly unnoticed, moving at nearly the speed of light. In a billion years, the sources of those cosmic rays will be entirely different stars, entirely different explosions, from entirely different corners of the galaxy. But the process itself, ancient violence quietly seeding the sky with particles, will likely still be happening. You are, in this very moment, gently touched by the afterglow of stars that no longer exist. Even the ground itself carries fainter versions of this same story. Deep within the Earth, radioactive elements like uranium and thorium decay at fixed, patient rates, releasing heat as they do. This heat is part of what keeps the Earth's core molten, which in turn sustains the planet's magnetic field, the invisible shield that deflects the solar wind and allows an atmosphere to persist at all. A billion years from now, that radioactive heat source will have dwindled further, cooling by degrees too small to notice across a single lifetime, but real nonetheless, the way a fire slowly settles into embers long after everyone has gone to sleep. We still don't know exactly when Earth's core will cool enough to weaken its magnetic field significantly. Estimates stretch out over billions of years, long past the billion-year mark we're exploring tonight. It seems like something that should worry us, and yet the timescale is so vast that it settles more like a lullaby than a warning. Long before the core cools meaningfully, the sun's slow brightening will likely have reshaped the surface far more dramatically. The planet has many futures layered on top of each other, each one arriving so slowly that none of them feel like an ending, only a very long unfolding. Above all of this, the stars themselves are not fixed points, no matter how still they look tonight. Each one is moving through the galaxy at tremendous speed, and over 1 billion years, the entire shape of the night sky will shift. The familiar constellations, the ones a grandparent might have once pointed out to you, the ones that feel like old friends, will slowly stretch and warp into new, unrecognizable shapes. Orion's belt will drift apart. The Big Dipper will lose its dipper shape entirely. Whoever looks up 1 billion years from now will see stars, certainly, but not this particular arrangement of them. Beneath that slow rearrangement, there is a softer truth. Most of the stars twinkling above you tonight will still exist 1 billion years from now, simply in different positions, tracing different quiet paths through the galaxy. Massive stars burn fast and die young in cosmic terms, but the smaller, dimmer stars, the red dwarfs, patient and slow burning, can live for trillions of years. Many of the faint points of light in tonight's sky are red dwarfs, quietly outlasting almost everything else, sipping their fuel so slowly that 1 billion years barely registers as a season in their extraordinarily long lives. Even now, as you lie still, light is arriving at your eyes, or would be if they were open, from stars so far away that what you'd be seeing left its source long before you were born. Some of that starlight has been traveling for thousands of years. A little of it, from the most distant visible galaxies, has been traveling for millions. In 1 billion years, an observer looking up will be seeing light that left its source around the time you are alive tonight, carrying, in its own quiet way, a photon's memory of this exact moment. We still don't know precisely how many stars are visible from Earth on any given clear night, though astronomers estimate somewhere around a few thousand under ideal, dark conditions. That number will not change dramatically in 1 billion years, even as the specific stars themselves shift and rearrange. The sky will still hold roughly the same scattering of light, the same soft density of stars, even though every single one of them will be a different point than the one you might glance toward tonight if you were looking, which you don't have to be. And so the sky, like the ground, keeps a kind of double life, mostly still on the scale of one human evening, and entirely rewritten on the scale of 1 billion years. Both are true at once. Tonight's sky is permanent enough to guide you home, and temporary enough to be, in the deepest sense, borrowed. You are looking at, and resting beneath, something that is both constant and constantly becoming something else. The way a river is never the same water twice, and yet is still, unmistakably, called by the same name. Deep beneath the ocean floor, in the dark, silent world where mid-ocean ridges quietly split apart, new crust is being born right now, cooling as it rises from the mantle below. This process, spreading at only a few inches a year, is one of the reasons continents drift at all. Over 1 billion years, entire ocean basins can open, widen, and eventually close again, swallowed back into the earth through slow, grinding subduction zones. The Atlantic Ocean, which feels so permanent on any map you've ever seen, is itself a relatively young feature, born less than 200 million years ago. A billion years from now, it may not exist in any recognizable form at all, folded back into the planet's long, patient cycle of creation and return. Beneath that ocean floor's rebirth lies something stranger still. The Hawaiian island chain, a long trail of volcanic islands stretching thousands of miles across the Pacific. Each island in the chain formed one at a time, as the Pacific tectonic plate slowly slid over a fixed, stationary hotspot of rising magma deep in the mantle. The islands you might picture as Hawaii today are simply the newest ones. Over 1 billion years, that same hotspot, quietly burning in one place while the crust above it drifts past, could produce an entire new archipelago, one island appearing every so often, cooling into black rock and slowly gathering green. We still don't know exactly how deep the hottest hotspot plumes originate, whether from the boundary of Earth's core or from somewhere shallower in the mantle. It seems like something we should know with certainty, given how much it shapes the surface above. And yet the deep Earth keeps its secrets well, hidden beneath thousands of miles of rock that no instrument has ever directly touched. What we know comes instead from patient inference. The bending of seismic waves, the slow arithmetic of heat and pressure. A kind of listening rather than seeing. Even as you rest tonight, the water in your body is older than you are, older than your parents, older than your species. The water molecules that make up roughly 60% of your body have likely cycled through oceans, clouds, glaciers, and other living things countless times before finding their way, however briefly, into you. In 1 billion years, most of that same water will still exist somewhere on Earth, moving through the same ancient cycle of evaporation and rain, unconcerned with which body it happens to be passing through at any given moment. You are, in this sense, a temporary resting place for something extraordinarily old. Coral reefs, delicate as they seem, are some of the oldest continuously renewing structures on the planet, with reef systems persisting, rebuilding, and shifting location for hundreds of millions of years. As oceans warm and acidify under a brightening sun, today's coral reefs may struggle, and many already do. But reef building, as a strategy for life, has survived multiple mass extinctions before. It seems likely that some form of reef-building organism, whether coral or something not yet evolved, will still be quietly assembling calcium structures on some future ocean floor, 1 billion years from now, indifferent to whichever species happens to be swimming past. Beneath that resilience lies a harder truth, spoken gently. The fossil record shows that life on Earth has weathered at least 5 great extinction events, each one clearing away the majority of species alive at the time. And each time, over millions of years, life rediversified into new forms, filling the empty spaces left behind. 1 billion years holds enough time for several more such cycles to unfold. Collapse and recovery, collapse and recovery, like a tide that keeps returning to shore no matter how far it seems to retreat. Extinction, on this timescale, is not an ending. It is simply part of the rhythm, and still, new species are being born even now, in this very moment, somewhere on Earth, through the slow accumulation of small genetic changes across countless generations. Evolution does not pause for anyone's convenience. 1 billion years is roughly enough time, biologists estimate, for entirely new kingdoms of life to emerge and diversify, the way animals once emerged from single-celled ancestors and plants once crept onto dry land for the first time. Whatever exists 1 billion years from now may be as unfamiliar to us as a whale would be to the algae from which, eventually, distantly, it descended. Right now, as you lie there, your own body carries traces of that ancient lineage. The mitochondria inside nearly every one of your cells, The tiny structures that generate your energy were once free-living bacteria over 1 billion years ago, before merging permanently with the ancestors of all complex life. They still carry their own small loop of DNA, separate from the rest of yours, a quiet reminder folded into every cell. You are not simply one organism. You are, and have always been, a very old partnership, still humming along, still working, even as you drift towards sleep. We still don't know precisely how that ancient merger first began, whether through slow cooperation or a kind of accidental capture that neither party could undo. It seems like something we should be able to reconstruct fully, given how central it was to the story of complex life. And yet the deep past resists easy answers, the way a dream resists being fully remembered the next morning. What remains is the outcome, that quiet, ancient partnership, still present, still functioning in every breath you take tonight. The Himalayas, the tallest mountains on Earth today, are the product of India slowly colliding into Asia, a collision that began roughly 50 million years ago and continues even now, lifting the peaks a few millimeters higher each year. Over 1 billion years, mountains like these will rise, and just as surely, they will erode away entirely, worn down by wind, water, and time into gentle hills and eventually flat plains. New mountains will rise elsewhere, formed by new collisions the current map cannot yet predict. The Earth's surface, in this way, behaves like a face that is always, ever so slowly, changing its expression. Beneath the Himalayas' slow rise lies an older mountain range, one you may never have heard of, called the Appalachians. Once, hundreds of millions of years ago, the Appalachians stood as tall as the Himalayas do today, jagged and severe. Time and weather have worn them down into the soft, rounded, forested hills many people know now as a gentle place to hike. 1 billion years is more than enough time to erase a mountain range entirely, grain by grain, and to raise an entirely new one somewhere else. Grandeur, on this timescale, is always temporary and always, eventually, replaced by something new. Even now, as you rest, the sediment of your surroundings, dust, sand, soil, is quietly recording the present moment, layer by layer, the way it always has. A thin sliver of rock, forming today in some slow river delta or ocean floor, will one day be examined by no one at all, most likely, but it will exist nonetheless, a patient, wordless record of this exact century. 1 billion years from now, that layer will be buried far beneath newer layers, compressed, transformed, perhaps folded into a mountain of its own, carrying, in mineral form, an echo of the world as it is tonight. We still don't know whether any trace of human civilization will remain identifiable 1 billion years from now. Cities crumble within thousands of years without maintenance. Plastic, so persistent within a human lifetime, breaks down into smaller and smaller fragments over centuries, though some geologists believe faint traces, in the form of unusual sediment layers, could theoretically persist far longer. It seems like something we should want to know, and yet even this uncertainty carries a kind of peace. The sense that the Earth has absorbed far larger disruptions before, and always, eventually, settled back into its long, patient rhythm. Even the sky itself keeps subtle records, meteorites, striking Earth's surface at a slow, steady rate, leave craters that erode within millions of years here on a geologically active planet, but linger far longer on quieter worlds like the Moon, where there is no wind or rain to soften their edges. 1 billion years is enough time for entirely new craters to be layered atop old ones, or for once fresh impacts to fade into barely visible scars. The moon's face, so familiar and unchanging to you tonight, will look different a billion years from now, though the change will unfold so slowly that 1,000 generations could watch it together and see nothing move at all. And still, gravity keeps its quiet, patient work. Tidal forces between Earth and the moon are not only pulling the moon away, they are also very gradually stabilizing Earth's rotational tilt, the same axial tilt responsible for the seasons you felt your whole life. Without the moon's steady gravitational anchor, some scientists believe Earth's tilt could wobble far more chaotically over long stretches of time, disrupting the reliable rhythm of seasons that living things have come to depend on. The moon, distant and pale, is doing quiet, essential work even as it slowly drifts away. A kind of steady companionship written into physics. Right now, as your breathing slows, somewhere on Earth, a volcano is releasing gases it has held since the planet's earliest days. Gases from deep within the mantle that have never before touched the surface. This is one of the ways Earth continues to replenish its atmosphere, alongside the slower cycles of erosion and weathering. Over 1 billion years, volcanic activity will likely continue in some form, though its patterns and locations will shift entirely as the continents rearrange themselves. The planet breathes, in its own way, through cracks and vents scattered unevenly across its surface, exhaling slowly, endlessly, the way you are exhaling now. We still don't know exactly how volcanic activity will change as Earth's interior gradually cools over such vast timescales. It seems like something that should have a clear answer, and yet even planetary scientists describe long-term volcanic forecasting as one of the more uncertain corners of their field. What is known is that the interior heat driving volcanoes today, much of it left over from Earth's formation and topped up by radioactive decay, is finite, though its slow decline will likely unfold across billions of years rather than one. Tonight, that decline has barely begun to matter. Even the air pressure around you, so unnoticed that you likely haven't thought about it in years, is a product of the exact thickness and composition of the atmosphere above you. Itself, a product of billions of years of volcanic outgassing, photosynthesis, and slow chemical balance. 1 billion years from now, if the atmosphere changes as models suggest, air pressure and composition could feel different in ways no one alive today could accurately imagine. The way describing color to someone who has never seen light would always fall a little short of the truth. Somewhere, right now, a star very much like our sun is nearing the end of its life, swelling into what astronomers call a red giant, its outer layers expanding outward in a slow, dramatic bloom before eventually shedding into space entirely. In roughly 5 billion years, our own sun will follow this same path, though that lies far beyond the billion-year mark we are exploring tonight. What matters for now is simpler. The sun above you is still comfortably young, still steady, still burning hydrogen at a pace so reliable that it has sustained nearly every living thing that has ever existed on Earth. 1 billion years from now, it will look almost the same from a distance, only slightly brighter, still faithfully rising, still faithfully setting, the oldest and gentlest clock any of us have ever known. Beneath that steady sunlight, there's a quieter, colder story unfolding much further away. White dwarfs, the dense, slowly cooling remnants of stars that have already finished their lives, drift through the galaxy like embers left over from old fires. They no longer generate new energy through fusion, only radiate away the heat they already hold. A process so slow that a single white dwarf can take longer than the current age of the universe to cool completely into a cold, dark ember astronomers call a black dwarf. Not one has ever existed yet, anywhere in the history of the cosmos. A billion years changes nothing about that particular patience. Some processes are simply too slow to have finished even once. We still don't know exactly how many white dwarfs exist within our own galaxy, though estimates suggest there may be as many as 10 billion scattered quietly among the living stars. It seems like something we should be able to count precisely, and yet space is vast enough, and these small, dim embers faint enough that many remain undiscovered, hidden in plain sight among far brighter neighbors. There's a kind of comfort in that. Not everything needs to be found or counted to be real. Some things are simply allowed to exist quietly, unnoticed, doing their slow, patient work of cooling in the dark. Even now, as you rest, somewhere far above the visible stars, entire galaxies are drifting through space, most of them retreating from our own as the universe itself continues its long, gentle expansion. The Andromeda Galaxy, however, is one of the rare exceptions, drawing closer to our Milky Way rather than farther away, pulled inward by gravity across 2.5 million light-years of space. In roughly 4 billion years, the two galaxies are expected to begin merging, a slow, graceful collision stretched across hundreds of millions of years, reshaping both into something new. A billion years from now, Andromeda will simply appear a little larger, a little closer, in the night sky above whoever happens to be looking up. Beneath that slow approach lies something almost impossible to picture, because galaxies are made mostly of empty space, with stars separated by trillions of miles from their nearest neighbors. Even a full galactic collision is unlikely to cause individual stars to crash into one another. Two great cities of light could pass through each other, in a sense, with barely a single direct impact, only a long, graceful rearrangement of gravity and orbit. It is a strange, quiet kind of violence, vast in scale, gentle in execution. The way a wave can move an entire ocean's worth of water without ever truly touching the sand it eventually reaches. Right now, as your eyes rest closed, the cosmic microwave background is passing through the room around you, an ancient, faint glow of radiation left over from a time when the universe itself was less than 400,000 years old. It arrives from every direction at once, uniform and quiet, a kind of leftover warmth from the very beginning of everything. In a billion years, that same faint glow will still be arriving, though stretched and cooled even further by the ongoing expansion of space. It is, in a very real sense, the oldest light there is, older than any star, older than any galaxy, older than the idea of time feeling long at all. We still don't know precisely what existed before that ancient light was released, or whether the question of before even applies in any way we could meaningfully understand. It seems like something we should be able to answer, given how much else astronomers have carefully measured and mapped. And yet some questions sit at the very edge of what physics can currently describe, resting there patiently, waiting for a better understanding, or perhaps waiting simply to remain forever, a soft and permanent mystery. Even as your body rests tonight, it is made of atoms forged inside stars that lived and died long before the sun ever formed. Every atom of calcium in your bones, every atom of iron in your blood, was created inside the crushing heat of some ancient star's core, or scattered outward in the explosive final moments of its death. You are quite literally built from stardust in the most precise and unromantic scientific sense of that phrase. A billion years from now, whatever new stars are forming, and whatever new elements they are quietly forging in their cores, will one day become part of some other living thing's body, in some other quiet room, resting the way you are resting now, deep within the rock beneath your feet. Wherever you happen to be resting tonight, there are minerals that have not changed in hundreds of millions, sometimes billions of years. Zircon crystals, tiny and remarkably durable, have been found on Earth dating back over 4 billion years, nearly to the planet's formation itself. They survive because of their crystal structure, resistant to weathering and chemical change in a way few other minerals can match. A billion years from now, some of those same ancient zircon crystals will likely still exist, unchanged, carrying within them a kind of geological memory older than almost anything else on the planet's surface. Beneath that quiet permanence lies something more fragile. Diamonds, often thought of as eternal, are chemically less stable than graphite under surface conditions, though the transformation between the two happens so slowly, without extreme heat, that it would take far longer than 1 billion years to notice any difference. In this sense, diamonds are less a symbol of permanence and more a symbol of extraordinarily patient chemistry, one so slow it might as well be permanent, the way a single held breath might as well be forever, if held for only a few seconds at a time. We still don't know the exact rate at which every mineral transforms under Earth's surface conditions, since so many transformations unfold across timescales longer than any laboratory experiment could ever directly observe. It seems like something we should have measured by now, and in truth, much of it has been carefully modeled, extrapolated from smaller, faster reactions observed under pressure. Still, there remains a gap between careful prediction and direct witness, a gap that 1 billion years is more than wide enough to fill, quietly, without anyone needing to check on it in the meantime. Even now, as your muscles loosen and your thoughts begin to drift, somewhere on Earth, an ice sheet is slowly advancing or retreating, part of a long climatic rhythm driven by subtle shifts in the planet's orbit and tilt. A cycle scientists call Milankovitch cycles. Over the past few million years alone, Earth has moved through dozens of ice ages and warm interglacial periods, each one lasting tens of thousands of years. 1 billion years holds room for thousands of such cycles, ice gathering and melting in a rhythm not unlike your own breathing tonight, in and out, and in again, patient and unhurried. Beneath that icy rhythm lies a warmer, more distant possibility. As the sun continues its slow brightening, some climate models suggest that Earth may eventually enter a phase where ice ages become impossible altogether. The planet's simply too warm for large ice sheets to persist no matter how the orbit shifts. This transition likely lies beyond the 1 billion year mark, further out in the planet's very long future. Tonight, ice ages remain part of Earth's rhythm. One more example of a pattern so large and slow that it can only be understood from a great enough distance, the way a forest can only be seen once you've stepped back far enough from any single tree. Right now, as you drift closer to sleep, somewhere deep in the Amazon or the Congo or another great forest, a tree is slowly growing, its rings quietly recording each passing year in a spiral of wood, one ring for every season it has lived through. Some individual trees alive today have stood for thousands of years already, patient witnesses to centuries of weather and change. No tree will survive 1 billion years, of course. But the practice of tree rings, recording time, layer upon layer, is itself a small, wooden echo of everything else we've talked about tonight. Sediment, starlight, ice, rock, all of it quietly keeping time in its own patient language. We still don't know exactly how forests, as ecosystems, will be distributed across the continents 1 billion years from now, since the very shape and position of the continents themselves remains uncertain that far out. It seems like something worth wondering about, gently, without needing an answer tonight. Perhaps there will be forests in places that are ocean floor today. Perhaps today's forests will have become desert, or seabed, or mountain range. The trees themselves cannot know, and neither can we, and there is something soft and forgivable in that shared not knowing. Even your own heartbeat, steady and unhurried as you rest, follows a rhythm that traces back through an unbroken chain of ancestors stretching back over 500 million years to the earliest animals that developed something resembling a heart at all. That rhythm has been passed down, generation after generation, adjusted and refined by evolution, but never entirely reinvented. 1 billion years from now, whatever creatures exist, if any trace of that same evolutionary lineage persists at all, may still carry some distant, transformed echo of a rhythm, not unlike the one quietly beating in your chest right now, keeping its own slow, private time. Far out at the edges of our solar system, beyond the orbit of Neptune, there lies a vast, dim region called the Oort cloud, a sphere of icy debris left over from the solar system's formation, stretching perhaps halfway to the nearest star. Comets that occasionally streak across our night sky, bright and temporary, often originate from this distant, frozen reservoir, nudged loose by the gravity of passing stars or the slow tidal pull of the galaxy itself. Over 1 billion years, countless stars will drift near enough to gently disturb this cloud, sending new comets tumbling inward toward the sun. Some of them arriving at Earth's orbit long after every person alive tonight has become part of the planet's long history. The sky, even in its quietest moments, is never entirely still, never entirely finished with its slow work of sending small, icy visitors our way. Beneath that distant icy shell, closer to home, Saturn's rings, so often imagined as ancient and eternal, are in fact surprisingly young by astronomical standards and surprisingly temporary. Composed mostly of ice and rock, the rings are slowly raining down onto the planet itself, pulled inward by gravity and eroded by radiation, a process some scientists estimate could cause the rings to disappear entirely within the next few 100 million years. 1 billion years from now, it is entirely possible that Saturn will circle the sun bare, ringless, the way it likely once did long before the rings formed in the first place, perhaps from the shattered remains of an ancient icy moon that wandered too close. We still don't know precisely how Saturn's rings first formed, whether from a destroyed moon, a captured comet, or debris left over from the planet's earliest days. Astronomers have gathered clues, careful and patient, from spacecraft that have passed close enough to measure the ring's composition and age. And yet the full story remains partially unwritten. One more quiet mystery orbiting patiently, visible through even a modest telescope, unresolved and unhurried, the way some stories are allowed to remain open at the edges without losing any of their beauty. Even now, as you lie there, Jupiter's great red spot, a storm larger than the entire Earth, continues to swirl in that planet's thick, banded atmosphere, a storm that has been observed continuously for well over a century and may have existed for centuries longer still. Storms of this size are stable enough to persist for extraordinarily long stretches of time, sustained by the deep, powerful currents of Jupiter's atmosphere. Whether it will still be swirling 1 billion years from now is impossible to say with certainty, though some scientists suspect Jupiter's atmosphere may always host storms of a similar size somewhere, even if this particular one eventually fades, replaced by a new storm born from the same deep, restless currents. Beneath Jupiter's swirling clouds lies a story of gravity, patient and immense. Jupiter's mass is so great that its gravity has shaped the orbits of countless smaller objects throughout the solar system, sometimes flinging comets and asteroids away entirely, and other times pulling them into itself, absorbing the impact so that smaller, more fragile planets like Earth are struck far less often than they otherwise might be. Astronomers sometimes describe Jupiter as a kind of quiet guardian, though it offers no guarantee, only probability, nudged slightly in Earth's favor. Over 1 billion years, this same gravitational shepherding will likely continue, largely unnoticed, a slow and steady kindness written into the mechanics of orbits and mass. Right now, far beneath the ocean's surface, hydrothermal vents continue releasing mineral-rich, superheated water into the surrounding cold, sustaining entire ecosystems that have never once seen sunlight. Giant tube worms, ghostly white crabs, and other strange, resilient creatures cluster around these vents, drawing their energy not from the sun but from chemical reactions involving sulfur compounds rising from the Earth's crust. These ecosystems have likely existed, in some form, for billions of years already, quietly persisting through ice ages, mass extinctions, and shifting continents that never touched their deep, dark corner of the world. 1 billion years from now, it is entirely plausible that similar vents in similar darkness will still be sustaining similarly strange and patient forms of life. We still don't know whether life on Earth first began near hydrothermal vents, in shallow tidal pools, or somewhere else entirely, though vents remain one of the leading hypotheses among scientists who study the deep past. It seems like something we should be closer to answering, given how much research has gone into the question. And yet the very earliest chapters of life's story were written before any rock could reliably preserve the evidence, leaving scientists to work backward from clues, careful and incomplete, piecing together a story whose true beginning may never be fully recovered. Even as your thoughts grow quieter, somewhere on the ocean floor, sediment is settling, one fine particle at a time, building layers so gradually that a single inch of seafloor mud can represent hundreds or even thousands of years of accumulated time. These layers, when later examined by scientists drilling deep cores from research ships, reveal a remarkably detailed record of ancient climates, ancient ocean chemistry, even ancient volcanic eruptions, preserved in careful, undisturbed order. 1 billion years of this same slow settling would bury today's seafloor beneath miles of new rock, folding this century's quiet sediment deep into the planet's long memory, indistinguishable, eventually, from any other layer laid down before or after it. Beneath that quiet accumulation, salt itself carries an old and patient story. Vast underground deposits of salt, sometimes miles thick, mark the locations of ancient seas that evaporated away entirely, leaving behind only their dissolved minerals, compressed over millions of years into thick, crystalline layers now buried far beneath the surface. Some of the salt on your kitchen table tonight, wherever you happen to keep it, may trace its origin back hundreds of millions of years to a sea that no longer exists, evaporated under a sun not so different from the one now, patiently, quietly, still shining outside your window. We still don't know the exact locations of every ancient sea that once existed and later evaporated, since so much of that history lies buried, undiscovered, beneath younger rock. It seems like something geologists should have mapped completely by now, and in truth, many have been found, carefully documented in mining surveys and drilling records around the world. And yet the Earth is large and patient, and still keeping some of its older secrets folded away in places no one has yet thought or needed to look. Even now, as your breathing settles into something slower, deep space itself carries a kind of profound, near-total silence, a vacuum interrupted only occasionally by the faint hiss of cosmic radiation or the rare passage of dust and gas. And yet, that silence is not truly empty. Even the emptiest reaches of space contain a few atoms per cubic meter, and threading quietly through it all, a faint hum of gravitational waves ripples in space-time itself, caused by distant collisions between black holes and neutron stars, events so violent and so far away that by the time their ripple reaches Earth, it moves the fabric of space by less than the width of an atom. Beneath that near-silent hum lies something almost too strange to hold comfortably in mind. Black holes, regions where gravity has grown so strong that not even light can escape their pull. Far from being empty or destructive in every sense, they behave, in a manner of speaking, according to the same physical laws as everything else, simply taken to an extreme. Supermassive black holes exist at the center of most galaxies, including our own Milky Way, quietly anchoring the slow, graceful rotation of hundreds of billions of stars around it. A billion years from now, that same quiet anchor will likely still be there, patient and invisible, holding the galaxy's shape the way a single steady hand might hold a spinning coin gently in place. We still don't know precisely what lies at the very center of a black hole, beyond the boundary called the event horizon, since no signal, no light, no information of any kind can escape from within to tell us. It seems like something physics should eventually resolve, and many careful minds continue working toward exactly that. For now, it remains one of the deepest, most peaceful mysteries available to wonder about. A place where the ordinary rules seem to quietly dissolve, unresolved and unthreatening, more curious than frightening. The way the dark corner of a familiar room is not frightening once you've lived there long enough. Even as your body settles further into stillness, the very atoms making up your fingertips, your breath, the blanket around you, are almost entirely empty space themselves. If an atom were scaled up to the size of a cathedral, its nucleus would be smaller than built this way, and will likely remain built this way long after lost quickly in the vast quiet between stars. If anyone, anywhere, is listening closely enough and happens to be facing the right direction at the right time, they might catch the faintest trace of it, a signal so weak by then it would be almost indistinguishable from the background hum of the universe itself. We still don't know whether any other intelligent life exists anywhere else in the galaxy, let alone the universe, despite decades of careful listening and searching. It seems like something we should have found some evidence of by now, given the sheer number of stars and planets involved. And yet the distances are so vast, and the timescale so long, that two civilizations could easily exist in the same galaxy, separated not by space alone, but by hundreds of millions of years, missing each other entirely, like two people walking through the same house at very different times, never once crossing paths. Even now, glaciers slowly carve their way across mountain valleys, grinding rock into fine powder as they move, shaping U-shaped valleys so distinct that geologists can identify a glacier's former path centuries after the ice itself has melted away. A billion years holds room for countless advances and retreats of glacial ice, each one reshaping the land a little differently, carving new valleys, smoothing old peaks, redistributing rock and soil across entire continents. The landscape, whatever shape it eventually settles into, will carry within it the quiet fingerprints of ice that came and went long before any observer was there to watch it happen. Beneath the planet quietly hardening at its very center, one imperceptible layer at a time. We still don't know exactly how quickly the inner core is growing, since it lies far too deep to measure directly. Its size and behavior inferred instead from the subtle way seismic waves bend and slow as they pass through it. It seems like something we should be able to measure more precisely by now, and scientists continue refining their estimates with each new earthquake's data. Still, the deepest parts of the planet remain, in some sense, permanently out of reach, understood only through careful, patient inference. The way you might understand the shape of a room by listening closely to how sound moves through the dark. even as you drift further from waking thought, there is a strange kind of stillness at the very smallest scale of matter, a place where classical certainty gives way to something softer and stranger. Quantum mechanics tells us that particles do not have fixed positions until they are measured, that they exist instead as a kind of probability, a blur of possible locations collapsing into one only when observed. It is a difficult idea to hold comfortably in mind, and physicists themselves have spent a century debating exactly what it means. And yet this strange uncertainty is not chaos. It follows precise, reliable mathematics, the same mathematics that will still govern the smallest particles a billion years from now, uncertain in detail, but never uncertain in its underlying order. There is something almost restful in that contradiction. The world being both unpredictable and perfectly lawful all at once. The way a wave is unpredictable in its exact shape, but entirely predictable in the fact that it will, eventually, always return to shore. Beneath that quantum uncertainty lies a much larger, slower kind of expansion. The universe itself has been growing since its beginning, not expanding into some pre-existing empty space, but stretching the very fabric of space itself, carrying galaxies apart the way raisins in a rising loaf of bread drift apart from one another, not because the raisins move, but because the bread between them grows. Over 1 billion years, this expansion will carry the most distant galaxies further away, their light stretching and reddening as it travels the ever-lengthening distance to reach us. Nothing about this expansion feels urgent from where you rest tonight. It is simply the universe continuing to do what it has always done, patiently, quietly, since the very first moment anything existed at all. We still don't know precisely what dark energy is, the mysterious force believed to be responsible for this accelerating expansion, even though it appears to make up roughly 70% of everything in the universe. It seems like something we should understand fully by now, given how much of the universe it accounts for, and yet it remains one of the largest, gentlest mysteries in all of physics, felt only through its effects, never directly observed. Invisible hand pushing everything gradually further apart, its true nature folded away somewhere just beyond the current reach of careful measurement and patient theory. Even now, as your body settles into its resting shape, somewhere among the billions of galaxies scattered across the visible universe, an entirely new star is being born, condensing slowly out of a vast cloud of cold hydrogen gas and dust, drawn together by gravity over the course of many thousands of years. Star formation has been happening continuously since the earliest galaxies formed over 13 billion years ago, and it will likely continue for a very long time still, though astronomers note that the overall rate of new star formation across the universe has been gradually slowing for billions of years already, the cosmos settling, ever so slightly, into a quieter and more contemplative middle age. Beneath that gentle slowing lies the story of stellar nurseries, vast clouds of gas and dust scattered throughout galaxies, where hundreds or even thousands of stars can form together in loose clusters, born from the same collapsing cloud, the way siblings share a single, common origin over millions of years. These young star clusters slowly drift apart, pulled in different directions by the gravity of the wider galaxy, until stars that were once neighbors, born together in the same cosmic nursery, end up scattered across vast distances, their shared origin no longer visible to any casual observer. 1 billion years is more than enough time for such a cluster to fully disperse, its members scattered like seeds carried by a wind too slow and too vast for any single lifetime to notice. We still don't know exactly which stars in tonight's sky, if any, were once born alongside our own sun in the same ancient stellar nursery some 4.5 billion years ago. It seems like something worth wondering about, gently, as you rest. That some distant, unremarkable point of light glimpsed on some other quiet night might share a common origin with the very star now warming the room you're falling asleep in. Two siblings, long separated, drifting slowly and independently through the galaxy's wide, patient turning. Even as your thoughts continue to slow, the concept of an ecosystem itself, the intricate web of relationships between predator and prey, plant and pollinator, fungus and root, is not a fixed thing but something constantly rebuilding itself. Species arriving and departing, relationships forming and dissolving, all while the overall balance somehow, remarkably, tends to persist. 1 billion years holds room for entirely new kinds of ecosystems to form, built from organisms not yet evolved, following rules of cooperation and competition not so different in their underlying logic from the ones quietly at work in whatever patch of nature happens to be nearest to you tonight. Beneath that ecological churn lies something surprisingly stable. Certain very simple organisms, like some species of bacteria and archaea, have changed remarkably little over enormous stretches of time, some appearing almost identical in the fossil record to relatives that lived over 1 billion years ago already. While more complex creatures evolve and branch rapidly, these simpler forms of life seem to have found something close to a stable equilibrium long ago, a shape that continues to work well enough that evolution has had little reason to alter it. There is a kind of quiet wisdom in that stillness, a reminder that not everything needs to keep changing in order to keep surviving. Right now, as you rest, somewhere deep underground, groundwater is slowly moving through porous rock and soil, sometimes taking decades or even centuries to travel just a few miles, filtered and purified by the patient, gradual passage through stone. Some ancient aquifers hold water that fell as rain thousands of years ago, trapped and preserved deep underground ever since. 1 billion years is far more time than any single aquifer could remain intact. But the underlying process, water seeping slowly downward, gathering, resting, eventually finding its way back to the surface again, will likely continue in some form for as long as rain continues to fall and rock continues to hold it. We still don't know the full extent of life that exists deep underground, in what scientists sometimes call the deep biosphere, kilometers beneath the surface, where microorganisms have been found thriving in rock pores, sustained by chemical energy rather than sunlight, some estimated to be extraordinarily old, dividing perhaps only once every few thousand years. It seems like something we should have mapped completely by now, given how much life has been found on the surface. And yet this deep, slow, hidden world remains only partially explored, patient and unhurried, existing on a timescale so different from surface life that 1 billion years might barely register as a handful of its own long, careful generations. Even now, as your body finally begins to feel heavy with sleep, the very concept of a species is less fixed than it might seem, blurring at the edges the further back or forward in time you look. 1 billion years ago, the ancestors of nearly every complex creature alive today were single-celled organisms, drifting quietly in ancient water. 1 billion years from now, whatever creatures exist, if any trace of today's life persists at all, will likely be as different from us as we are from those distant, humble ancestors. Species are not fixed points but slow, continuous rivers, each generation blending gently into the next, with no single sharp line marking where one ends and another begins. Beneath that gentle blurring lies a comforting mathematical truth. If you trace your own ancestry back far enough, every single living thing on Earth today, plant, animal, fungus, bacteria, shares a common ancestor, some single population of organisms that lived over 3.5 billion years ago, long before anything resembling a tree, a fish, or a human ever existed. In this sense, the towering oak outside your window, the quiet moss growing in the cracks of a sidewalk, and you yourself, resting here tonight, are all, distantly, softly, part of the same enormous family, however many branches separate you now. We still don't know precisely what that earliest common ancestor looked like, since no fossil has ever been found old enough or well preserved enough to show it directly. It seems like something we should be able to picture clearly, given how central it is to the story of everything alive today. And yet it remains a soft, reconstructed silhouette, pieced together from genetic clues left behind in every living thing since a quiet ancestor known only through its descendants. The way you might understand a person you never met through the stories carried forward by everyone who came after them. Even as sleep continues to gather at the edges of your thoughts, entropy, the tendency of all systems to move gradually toward disorder, continues its slow, patient work throughout the universe, from the coffee cooling in an abandoned cup to the eventual fading of stars themselves. And yet entropy is not something to fear tonight. It moves so slowly, on such a vast scale, that 1 billion years barely registers as the faintest beginning of a process that will ultimately stretch across trillions of years before the universe reaches anything resembling true stillness. Tonight, entropy is simply the reason a warm room slowly cools, the reason ice slowly melts, the reason your own body slowly settles into a comfortable, quiet rest. Beneath that quiet drift toward disorder, there is a strange and reassuring counterbalance: life itself. While the universe as a whole tends toward disorder, living things temporarily and locally organize matter into extraordinarily intricate, ordered structures, borrowing energy from the sun to build cells, bodies, ecosystems, entire civilizations, all while the universe's broader arrow points the opposite direction. 1 billion years holds room for life to continue this same quiet defiance, gathering order out of chaos, again and again, in whatever form it eventually takes, a small, persistent exception to the universe's much larger and much slower rule. Right now, wherever you happen to be resting, the ground beneath the building around you is part of a tectonic plate that has existed in some recognizable form for hundreds of millions of years already, carrying the land slowly across the surface of the planet the entire time you and everyone you have ever known have been alive. 1 billion years from now, that same plate, or whatever it has become through countless collisions and separations, will still be carrying whatever life exists, then slowly, patiently, the way it has always carried everything resting upon it, without complaint, without hurry, simply continuing. We still don't know exactly where the continents will be positioned 1 billion years from now, since so many small, unpredictable factors influence the long, slow dance of plate tectonics. Some models suggest the land may gather near the equator. Others suggest a configuration closer to the poles. It seems like something that should be predictable with enough careful modeling, and in truth, scientists have made thoughtful, educated guesses. And yet 1 billion years is long enough that small uncertainties compound into large ones, leaving the future shape of the world a soft, open question, patient and unresolved, much like sleep itself, which cannot be forced, only allowed to arrive in its own time. Even now, as your breathing grows slower and steadier, somewhere on Earth, Right this moment, an animal is falling asleep too, tucked into a burrow, nestled in a nest, curled beneath the shelter of leaves or stone, following the same ancient rhythm of rest and waking that has existed since the earliest animals with nervous systems first evolved hundreds of millions of years ago. Sleep itself, in some form, appears to be almost universal among complex creatures, a deeply old and necessary pattern, present in fish, birds, insects, and mammals alike. A billion years from now, whatever creatures exist, they will very likely still need to rest in their own way, following their own version of this same old, patient rhythm. Beneath that shared rhythm lies the final, gentlest thought of the evening. Everything explored tonight, the drifting continents, the aging sun, the cooling stars, the ancient water inside your own body, exists on a timescale so vast that no single life could ever witness more than the tiniest, quietest sliver of it. And yet you are here, briefly, warmly, resting inside this one particular sliver, part of an unbroken chain of existence stretching back over 3.5 billion years, and reaching forward, quietly, patiently, toward whatever comes next. You do not need to understand all of it tonight. You only need to rest inside it, the way you always have, the way everything always has, for exactly as long as you are here. There is something quietly humbling about all of this, and something quietly kind about it too. 1 billion years is long enough to erase mountains, to rearrange oceans, to rewrite the very shape of the sky above you. And yet you are here tonight, made of the same patient atoms that have been drifting through stars and stone and water since long before anyone thought to name them. You are not separate from any of it. You are simply the part of it that happens to be resting right now, in this particular room, on this particular night, breathing slowly, the way everything eventually does. Scale, on a night like this, is not something to fear. It is something to be held by. The mountains will erode, and new ones will rise in their place. The stars will drift into unfamiliar shapes, and somewhere, new stars will quietly begin. You are small against all of it, the way a single wave is small against the ocean, and yet the ocean is nothing at all without each and every wave that has ever risen and settled back down. You belong to this vast, unfolding story simply by existing inside it, tonight, for however long tonight happens to last. In and out. Not fast, not urgent. Somewhere in your body right now, water older than any living thing is moving quietly through you, borrowed briefly, the way it has been borrowed and returned countless times before, by rivers, by clouds, by roots, by other bodies resting in other rooms, in other centuries. In and out. The same slow rhythm carried by tides, by seasons, by the patient stretching of continents across the face of the earth. You do not have to hold on to any of it. You only have to let it move through you, the way it always has, the way it always will. And you can rest now. Everything is still. If you happen to still be awake, you can go ahead and watch the next chapter now. If not, that's all right too. Good night.